Hey, there you are. Welcome back. This is Unit 3, Topic 1, Lesson number 6. I'll make this one quick because I know I ran late on the last one. This is correlation versus causation, which is a fairly easy concept. So whether or not one causes another to occur, so in this case we're talking about categories, whether one category is causing another one to occur, is causation. Now, starting us off with a warm-up. Now, I don't have a graphic calculator, which is kind of unfortunate, but I will talk you through the steps that you need. So all you need to do is grab your graphing calculator, TI 83, 84, or whatever it might be. Might be an 89 or an Inspire, I guess. Create a scatter plot to align the best fit. This has to be done in a graphing calculator. There's no other way of doing it because your calculator uses all sorts of algorithms in order to take all of the data and make sure that it's all used in order to find the line that best fits that data. Or it could be a curve, a best fit as well. It doesn't have to be a line that best fits the data. All right, so now what you're going to do is, first we're going to plot all this data. So ball drop height and ball drop bounce height. So this is going to be the drop height. And this is going to be the bounce height. All right, so I'm going to plot all the data. So 12, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3. 18, 7. Well, this is 12, 13, 14, 15. Oh, you know what? I'm going to have to make each worth 2 in this case. So I'm going to go 2 in both directions. 2, 4, 6, 8, 10, 12. 2, 3. Be halfway up. 18, 2, 4, 6, 8, 10, 12, 14, 16, 18, 2, 4, 6, 7 would be in between. 24, so this is 18, 20, 22, 24, 13, 2, 4, 6, 8, 10, 12, 13, right there. 30, so this is 24, 26, 28, 30 would be right at the end. 19, 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. This is looking pretty linear here so far. 36, 30. Now I kind of ran out of room here. 32, 34, 36, 20. Well, the last one was 19, so it'd have to be about right there. All right, doesn't look so linear anymore. 42. Okay, I've completely run out of room here. 30, 36, 38, 40. Okay, so maybe around right here. 42, that's right, 42, 22, and that would be, this is 20, so it'd be one box higher, about right there. Now, I'm just going to stop right here, but you can clearly see what I'm doing, so I'm creating a trend line. So once you've got that, it looks pretty linear in this case, pretty close. So what you're going to do is you're going to take your graphic calculator, and you're going to go to Stat for statistics. I believe it is below the clear button, I think, something like that. Find Stat, then go to Edit, and then Edit again, press Enter again. And then what you're going to do is you're going to have a place where you're going to put the data in. So you can put these numbers in line 1, so it's basically just a table, and it says line 2 right here. And you put all the numbers down, you put 12, Enter, 18, Enter, 24, Enter, 30, Enter, and so forth. Once you put all these data in, then you're going to go to the right and do all these data next. And it has to be equal amount of data because otherwise it's going to give you an error message. So you must have, for each X, you have to have one Y output answer. All right, so then once you entered all the data into the edit, then you're going to go back to Stat. You're going to go to Calculate, which is 1 to the right. And then you're going to go down to where it says Line of Regression. Now, if my memory serves me right, I believe it's number 4, but I'm not quite positive. So whatever it says on your calculator for line of regression, and then you're going to press Enter, Enter again, and then it's going to tell you the slope, which is the M, and the y-intercept, which is the B, and it's going to tell you that you put it all together, you got yourself your equation. So it just basically tells you the answer of the equation, the straight line that goes through the middle of the data. So that's really what a trend line is. A trend line shows you the trend of the data. You know, is it going up? Is it going down? Is there no correlation? So it's telling you how fast or how close. Well, no, actually that's going to be coming up. Not just yet. So I'm going to get to that. So when you have a scatter plot, when you look at this data, I say to myself, well, hey, this looks like it's primarily the data is increasing. Now, is all the data on that straight line that I've created? Now, I know it's not so straight, but it's close enough. No, it's not. So not all the data is exactly close there. And we'll get to that correlation coefficient later on. We'll talk about that in a later video. That's kind of what I was almost trying to tell you in the during the warm-up. correlation coefficient. What does the data in the scatter plot below suggest? Well, it suggests that typically the more grip strength a person has, typically the more arm strength that they're going to have, because it's positive correlation. It's increasing. Now, does everybody who has grip strength have arm strength also? No, not necessarily. Some people actually work on their grip strength. A lot of people like to use those grip balls. And some people also like to pump iron, lift weights a lot. In that case, depending on what kind of weight you're lifting, you may or may not be getting grip strength. If you're using those free weights, maybe you got to hold on to them, those dumbbells like this. Maybe you are getting some grip strength. So it just kind of depends. Or maybe you're just naturally born with a lot of grip strength. So, like I said, there's not a direct correlation because the dots are scattered out, but there is a correlation. There is a positive correlation. As one increases, the other one also increases. Now, when you look at these two data plots, this one definitely looks like a curve of best fit. It looks like an exponential function would fit this perfectly, a hyperbola. This is life expectancy. So the older you get, the more money you end up spending on healthcare. Well, that does make sense because when you get into your 80s and your 90s, maybe even into your 70s, healthcare starts to cost more. It costs more for older people than it does younger people, healthier people, people in their 30s, 40s, 20s, 50s. Typically don't get sick as often, whereas a person who is older is more often than more likely to get sick. So people when you get here into your 80s are going to be spending more on their healthcare. All right, health expenditure, how much you're spending. Now over here, this one, I do see a correlation here. This is a perfect correlation. You can see the data is curving perfectly. There is not much of a correlation here. There is a correlation, and it is a negative correlation. For those of you that don't understand football, so basically a sack is a good thing on defense. It means that you have taken down the quarterback and stopped him from getting a play. Now, just because you get lots of sacks doesn't necessarily mean that they're not going to score any touchdowns on you, because you can get a sack in one play. So those of you who do know football know what I'm talking about. You can get a sack on one play, and then in the very next down, they score a touchdown on you on the very next play. Just because you got a sack does not necessarily stop them from getting touchdowns. So normally, there is a correlation, and I do agree with that. There is a trend of negative trend. Typically, the more touchdowns you give up, the less sacks you probably got. Or you could say the more sacks you probably got typically means the less touchdowns you gave up. There is a correlation. There's just not a direct correlation. And the correlation coefficient, it's going to be more weak. It's not going to be very strong. We'll talk about that more, I believe, in the next video. All right, so I just talked about both of these. Describe the difference between positive and negative correlation. Positive means it's increasing. Negative means it's decreasing. Fairly easy. Now, this is a perfect example of no correlation because the jersey number that a player wears has nothing to do with their age. Just because they're wearing the number 50 does not mean that they are 50 years old. No, it doesn't. Jersey number and age have no correlation. So it's going straight across because there is no positive, no negative correlation in this case. Data is just going straight across for absolutely no correlation whatsoever. All right, so that one was nice and easy. So next one, which graph could be causation? Causation means that one causes the other to occur. So remember we talked about this. Typically, the more sacks you get causes the other team to score less touchdowns. So yeah, I would say this is a fairly weak correlation, so therefore it's not a very strong causation in this case. It's pretty weak causation because, like I said before, you can get a sack and then another sack on second down, and then on third down they just throw a touchdown, and that basically meant nothing. Those two sacks were for nothing. All right, now in this one, it's very, very, very strong correlation, which means there probably is going to be some causation involved. The more time you study typically means your score is going to increase. Now, just because you study for 3 hours does not guarantee you're going to get 100%. It's not a direct correlation, but there is a correlation there. People who don't study will score lower than the people who do study. All right. So that's the difference in causation. And then we got the shortest warm-up of all time. Homework of all time. This one's definitely a negative correlation because it's decreasing. But I'll be honest with you, I don't really like these two questions very much. I thought maybe there'd be one example of each, but it really isn't. If I'm really struggling here to do this, I would say that this is positive correlation because you can draw a line that goes like this. But yeah, I'm not really determined that that's really the right answer. So I guess you could call this positive. This is definitely negative correlation. Okay, that's without a doubt. 6 and 7, I think, are debatable. Now, I know some of you look at number 7 and you think to yourself, hey, this is definitely negative correlation because I'm seeing a trend going down. But you know what? I want you to cover this up and get rid of that dot. Do you really still think it's going down? Because I don't. I really think that this is no correlation. One piece of data should not be causing a correlation. If you take away just one of the many pieces of data, it should not cause the correlation to be any different. So in this case, I would call this no correlation, and I think this is also no correlation, but I guess there's that very, very, very weak positive correlation. So if I had to give one example of each, that's probably what I would say in these 3 examples. Please give it a like to help you learn something about causation or correlation, and subscribe if you haven't done so already. Thanks again for watching. I look forward to making more videos in the future.